I'm Doralius. You see me in such epic, fine, quality educational videos such as Doralius and Hydrate, Part 4, and Doralius and the Deliverers of Electrons, Part 2.
Okay, for this video we're looking at naming compounds that have water attached to them, which means we talk about hydrating. Hydrates. Now, what's exactly a hydrate? Well, hydrate is any chemical formula with water chemically attached to the molecule. Okay? That's a pretty important idea. There are some chemical compounds out there that water will attach to chemically to it. Could be one water, could be two, could be as many as 8 or 9. It depends on the compound. Now, can it be separated from the compound? Sure it can. You just add a little heat and watch the water go bye-bye. But there's hydrate, so those are chemical compounds that have water chemically connected. There's also anhydrous. Anhydrous means this chemical compound has no water in it whatsoever. You could look at it as dehydrated if you want. Really, the technical term is anhydrous. Okay, let's get this started. Now, when we are naming hydrates, there's a couple of things you got to look at. We have to look at the name of the chemical compound itself. Also, we have to remember, there's a notation there. There's a dot. Okay? So, let me expand upon this a little bit. So when you're looking at something like this, how do we show this? How do we show that something is a hydrate? Here's an example of NgCl2. Well, that's magnesium chloride. Now, notice we don't say dichloride and all that because it's a metal with a non-metal. Magnesium is the metal, chlorine is a non-metal. Now, you notice that there's a dot there. Now, in math, the dot would represent multiplication. Okay? In math, the dot would represent the multiplication. But in chemistry, it is something completely and totally and obviously different. It means, hey, we got water chemically connected to this chemical compound. Now the dot, and then we have 7H2O. So that means we have magnesium chloride with 7 H2O, 7 waters, count them, 7 waters chemically connected to the magnesium chloride. So what do we call it? Well, we're going to call it in 2 parts. The first part is the name of the compound itself, magnesium chloride, and then because there's 7 waters, we always use the word hydrate to tell us it's a water, and then the prefix, which you learned in previous videos, okay, that tell us how many of these waters are connected. So, magnesium chloride, heptahydrate, hepta meaning 7, hydrate meaning water. So it literally means magnesium chloride with 7 waters. That's pretty much it. Now let's try another one. Here we have CrCl2, okay, dot 3H2O. Well, CrCl2, you'd have to go back and look, because remember, this is a metal with a non-metal. Chromium is the metal, chlorine's a non-metal, okay, which in this case is a chloride because it picked up electrons. You have dot 3H2O. So you have chromium 2 chloride. Trihydrate. Tri meaning 3. So mono is 1, di is 2, tri is 3, tetra is 4, penta is 5, hexa is 6, hepta is 7, octa is 8, nona is 9. Not 9, meaning no in German. 9, the number, no number 9. And then deca means 10. 10, 10, 10. hydrates. Okay? So let's move on here. So let's do a couple more examples here. So identify the following hydrates by writing their formula. Well, this is CuSO4, and in the interest of time, I'm going to go ahead and say, all right, this is a -2 charge, the SO4, because you'd have your ion chart. And that means this copper, there's only one, so it has to be a +2, which means Roman numeral time, because you have copper in more than one form. So that's going to be written as copper, Roman numeral 2, sulfate. Yay! We got half the formula done, but now we have the other part right here, right there, the 5H2O. So that means pentahydrate. Copper 2 sulfate pentahydrate, because penta meaning 5, hydrate meaning water. Okay? Let's take a look at another one. So here you had a formula. Here you're given the name of the actual compound. So let's break it down. Cadmium is Cd with a +2 charge to it. It's a heavy metal. Chloride is Cl with a -1 charge to it. Okay, dihydrate, di meaning 2, hydrate meaning H2O. So I think we can reasonably figure out our formula here. Now, if you don't remember how to balance an ionic equation, go back and check the video for part 1. Okay? Binary ionic equations. Okay? Because if you don't know how to do this, you need to check out the video. And click the like and subscribe. Okay. So with this, you may remember we use the crisscross thing, so we know that it is CdCl2, right? Because that's going to balance, that's got to equal 0. The hydrates never affect the compound. That compound was already balanced to begin with. Then you put in the dot, okay? Then you have dihydrate, 2H2O. Right here. Right here. And there you have it, folks. So I've got a couple of examples. Let me see if I can work a couple more. Okay. All right, let's take a look at this one here. CuCl2.3H2O. Let's see what we got here. Okay. All right, some things I know I got to work with here. Okay. Huh? Hang on, it's doing something weird. Oh my goodness. Okay, let's do this. All right, let's close it. Oops. All right, let's go back. All right, let's go back here. So, here we go, CuCl2.3H2O. Well, already, immediately, I know this has to be a hydrate. Automatically. Water, hydrate. Hydrate, water. The 3, that's tri, that's the prefix tri. So I know I got a trihydrate in there. So I can actually write that out here. Trihydrate. Okay? Now look at the CuCl2. I know it's a copper chloride, but what kind of copper is it? Because that's when you look up your ion chart. I know that copper could be a +1 or a +2. How will I know? As Whitney Houston would say, how will I know? Yeah. So I know that the chloride here there's 2 of them. Each one is a -1 charge. So I know I got a total charge of -2, which means the total charge of copper has to be a +2. Now, there's only 1 copper there. So that's got to tell us the copper must be a +2 charge. Because remember, this has to equal 0 to be balanced. So I'm going to go with copper, Roman numeral 2, chloride trihydrate. Woo! Okay, I think we got time for one more, do we? Yeah, we do. Okay. Let's look at aluminum bromide tetrahydrate. Big. Okay. Bromide. Well, I know that bromide is Br with a -1 charge to it. I know tetra means 4. And notice I'm going through the process of elimination here. Hydrate meaning H2O. So it's a reasonable thing for me to say I'm going to have a 4H2O in this because I've got tetra and hydrate there. Bromide is a bromine that picked up an electron and it changed. So that means, guys, it became a bromide. Okay? Aluminum, now you got to check it out. Aluminum is an Al with a 3+. So that's what we have through the power of the crisscross. And again, if you don't remember what the crisscross is, or you don't know how to balance the aluminum and the bromide, remember, go back and check out part 1 on naming binary ionic compound formulas. Click like and subscribe! So with that, we know that it's going to be Al, and there's got to be 3 bromides in order to make this happen, because they've got to cancel. Don't forget the dot. You don't put the dot, it's not going to count. 4H2O. So AlBr3.4H2O. That's it. That's all that it is in the nutshell, ladies and gentlemen. So with that, that's it for how to work naming hydrates. I hope this has been a benefit for you guys. Okay, and well, I wish you the best. Good hunting. No, really, click like and subscribe. Bye.